I'm here today to talk to you about our vision for the textile industry, which includes a world with zero pollution from textile dyeing and finishing. I'm going to tell you a little bit about how we aim to achieve that by introducing you to our two products, Endeavour and Navara. So Endeavour is for dyeing and Navara is for finishing. So if I move us forward to our first slide, just to introduce us as a company. So the company is called Alchemy Technology. We're based just outside of Cambridge in the UK. And our mission is to deliver a world with zero pollution from textile dyeing and finishing. And we're aiming to do that by harnessing our breakthrough new technology for delivering colorants and finishes to fabrics in process designs which radically reduce the energy consumption, wastewater emissions, and cost of delivering colorants and finishes to fabrics. So our technologies are really aiming to deliver three main benefits. First is a breakthrough in sustainability. The second is a transformation in cost structure. And the third is delivering the vision of digital manufacturing in textiles by delivering on-demand digital manufacturing, enabling manufacturers to make to order rather than make to stock. So just to tell you a little bit about the problem that we're addressing. The problem that's faced by the textile industry is really the problem of old technology. So dyeing and finishing is currently performed using technologies that haven't changed significantly for the last 50 years. So dyeing and finishing generates 20% of the world's water pollution. It's the number 2 cause of water pollution on the planet. It consumes a large amount of energy. So the textile industry produces around about 10% of global carbon dioxide emissions. Of that, about 35% is dyeing and finishing. So 3% of global carbon dioxide emissions are associated with just the step of applying colorant and finishes to fabrics. And finally, dyeing and finishing is actually a very costly process. So the significant amount of energy used in the process, the significant waste in chemistry. So in many dyeing processes, maybe 30%, 40% of the chemistry doesn't end up on the fabric, it ends up in the wastewater stream. And there's also a significant amount of waste in textile manufacturing because of the complexity of the supply chain. There's a significant amount of overproduction of fabric, leading to a significant amount of waste and loss in revenue through discount. In recent months, the issue of energy cost and energy availability has become a particularly acute issue in the textile industry. So as you can maybe see from this first slide on energy, there's been two major developments over the last 6 months. One is in China in particular, there's been a government-led shutdown of textile industry factories due to their high energy consumption. And secondly, the cost of energy has increased significantly in the last 6 months. So you can see in this chart on the right-hand side of this slide, the gas price in Europe has increased pretty much 3 times since 6 months ago. And so we're seeing a really difficult operating environment for many textile manufacturers. So this situation is likely to continue and accelerate. So if we look at the global production of fabrics and fibers, we see a significant increase in both absolute consumption and per capita consumption. So as the world gets richer, the population grows, fast fashion becomes a norm in the delivery of clothing to consumers. We can forecast a significant increase in the amount of textile being produced, the amount of carbon dioxide emissions. So we would expect to see over 2.5 gigatons of carbon dioxide being emitted by dyeing and finishing processes by 2050. And we would forecast to see 10% of global carbon dioxide emissions by 2050 being attributable to textile dyeing and finishing. So it's really a very significant and growing global problem. So in terms of what we're trying to do at Alchemy, is we're trying to really change the game, transform the way that fabrics are dyed and finished, such that we can address this significant global energy consumption problem, which today is attributable to 3% of global carbon dioxide emissions, or around about 700 million tons, 0.7 gigatons of carbon dioxide emissions. And we're looking to reduce that by 85%. So we're looking to make a really substantial change in the amount of energy that's required to apply colorants to fabrics and apply finishes to fabrics. And so what I'm going to do in this presentation is tell you in a little more detail about how we plan to do this with our Endeavour and with our Navara products. So the first product to tell you about is what we call Endeavour. So this is a waterless smart dyeing process. It's a machine product. And if I move forward to this slide, you can see a bit what it looks like. It's a roll-to-roll system for taking undyed fabric as an input, applying dye in a way which is defined by our technology platform, fixing the dye stuff into the fabric by either diffusing it in or reacting it with the fabric or adhering it to the fabric, and producing a roll of dyed fabric which can then be used for garments or other applications. And you can see here on the right hand side a garment that was manufactured using our Endeavour dyed fabric. So this was marketed by H&M as part of their rental collection. It's called the Air Top. It's 100% polyester apparel fabric. And in terms of what the Endeavour machine can deliver, there are four main benefits we can deliver with this machine. So one is energy reduction, and we can talk a bit more about that shortly. We can deliver around about 85% energy reduction in polyester dye. Wastewater reduction, so really significant reductions in wastewater emissions. So in the case of polyester, over 95% of the wastewater is eliminated from the process. Lower cost, so we can basically halve the cost of dyeing, primarily through energy reduction and also through chemistry reduction. And through digitalizing the dyeing process, we can reduce the amount of waste in the supply chain. So these are really the four main benefits of adopting our Endeavour digital dyeing process. So to explain a bit more about how we do this, it's maybe useful to rewind or take a slightly higher level view of how dyeing is done today, how dyeing is performed today. So a question to ask is, would you paint a car by dipping it in paint? And the answer to that question for most people will be no. Why is that? Because if you were to dip a car in paint, you end up with a contaminated bath. You have to apply a very large amount of paint through your dipping process. You would generate a lot of waste water, which would be the paint that wouldn't be transferred to the car. And if you had to dip your car in hot paint, you would have used a lot of energy to heat up the water. And so this is basically how fabrics are coloured today, through immersion processes. And this immersion process is a fundamentally inefficient way of applying colorants to fabrics. So it was invented many years ago, perhaps millennia ago, when fabrics were first being dipped into baths, and has persisted to the present day. And this is really the core reason why dyeing and finishing is such an energy intensive manufacturing process. And so what we're looking to do at Alchemy is to really change the game, change the way colorants are applied to fabrics. And we're doing that using our proprietary liquid application technology, which delivers high velocity droplets of fluid into fabrics. So we use a high velocity droplet We control the airflow around the droplet to ensure really good penetration of the droplets into fabrics. And what we're able to do is demonstrate that we can get really good 3D penetration of colorants and finishes into textile fabrics. And so what this means is that you can apply colorants and finishes at high concentration, so you don't need the energy to heat the water you need in immersion processes. And we can penetrate the colorant or finish deeply into the fabric such that you can achieve really good homogeneity of application to the fabric. So overcoming many of the issues associated with bath immersion, where you see issues with aggregation, heterogeneity, and poor quality in application of these chemistries to fabrics. In terms of what this means from a textile dyeing perspective, we're focusing on three main properties of our process. So one is color consistency, one is color fastness, and one is fabric handle. In terms of color consistency, we can achieve really exceptional color consistency. Delta E values of less than 0.5 for front to back, left to right, end to end of a sample fabric. So it's a 20-meter piece of fabric that was sampled from our process. This is typically quite below parallel specifications of around about 0.7, 0.8. We're able to apply our process to a wide range of fabric structures, from quite dense woven structures through to very open spacer fabrics, to knitted fabrics, jersey fabric. So we've shown that our Endeavour process can be applied to many different fabric types. And in terms of color buildup, this slide hopefully explains a little bit more about how we're able to achieve good color fastness with much less energy. So what we're doing in terms of dye application is just applying the right amount of dye to the fabric to achieve the shade that's required. So unlike bath dyeing, where typically you're overdosing the fabric and leaving dye stuff behind in the application liquid, 100% of the dye that we apply to the fabric is delivered to the fabric. And so we can see in this example here, which is using a DyeStar's Dynix XF2 high wash fastness dye, that we're able to control the color strength, so control the tone using our digital technology. But we're also able to show really good color fastness. So color fastness to washing, in this case, above 4 out of 5. Color fastness to crocking above 3 to 4 out of 5. Such that we can achieve, commercial specification color fastness, but without using any of the washing processes that would be required in traditional bath dyeing processes. Okay, so to explain a bit more how this works, what's actually happening in the textile is that we're applying the colorant as a picoliter or nanoliter droplet into the textile. This colorant droplet remains at high concentration within the textile. We're using infrared energy to activate fixation processes. So that's both diffusion-based fixation processes in polyester and chemical reaction-based fixation processes in the case of cotton. By keeping the chemistry at high concentration throughout the process, we're able to take fixation processes to a higher level of completion more quickly than is possible using a bath process. So this is kind of one of the fundamental principles behind our technology. So to then make the comparison between our Endeavour dyeing process and a traditional jet dyeing process, we can maybe just talk through the processing sequence that we use in Endeavour versus what's used in traditional jet dyeing processes. So in a conventional or traditional jet dyeing system, you might be using a 5-to-1 liquor ratio to apply the dye stuff to the fabric, which means for every ton of textile, you're adding 5 tons of liquid. This liquid is heated to 130 Celsius, so it's very hot, which requires a lot of energy. The dye is typically then overdosed and on the surface of the fabric and needs to be washed off. And so typically for polyester, you might be using between 10 and 35 tons of water to every ton of textile, typically at high temperature, to remove the excess dye stuff for finishing the fabric and heat setting it. In our process, what we're doing is we're just applying the right amount of dye stuff to the fabric. So we're not using hot water to apply the dye. We're applying the dye at room temperature. We're fixing the dye stuff into the fabric in line. We apply a softening process to achieve the target hand feel. And we're also drying the fabric and heat setting it in the center, leading to the final dyed and finished fabric. So if we compare these two processes from a water perspective, even taking the best case for jet dyeing, which is a very light shade with a highly optimized factory, we're talking about 5:1 liquor ratio to apply the dye, 10:1 liquor ratio to wash off the excess dye. Typically, it's much worse than this. It might actually be more like 30:1 to do the wash off, or 40:1 to do the wash off. If you compare the jet dyeing process to our process, we're reducing the amount of wastewater generated by over 95%. It's really a dramatic change in wastewater emissions. If we also look at what happens from an energy perspective, because we're eliminating the high temperature dye application process, we're eliminating the wash off heated water, we're reducing the energy consumption by over 85% compared to jet dyeing. So again, really dramatic reduction in energy consumption, which then translates to a reduction in carbon footprint. In terms of the applicability of our process, it's broadly applicable. So we've used it with a wide range of commercial dye systems. We're not using anything special in terms of chemistry. So we're using commercially available, for polyester, commercially available dispersed dyes. We're using a digital process to get the color right first time. And we have a laboratory scale version of the Endeavour process that's called the color hit, which allows you to do laboratory scale shade matching. And we ultimately would envisage a future where we could perhaps eliminate manual color matching altogether and fully digitalize that process. And the Endeavour process principle is also applicable to cotton. So we have a cotton process in development, which we'll be announcing later on this year, which delivers similar benefits in terms of energy and water consumption reduction as our process for polyester. And so broadly speaking, it's driven by the same principles of eliminating the high temperature dye application process and eliminating the wash off, or much of the wash off process. If you compare our wastewater emissions for cotton dyeing using reactive dyes, and you can see here the multiple stages of wash off required for dyeing cotton with reactive dyes using a traditional process, we can reduce wastewater emissions by above 85% cotton, and we can also reduce the energy consumption by over 70%. So we see very similar benefits when we're applying our Endeavour process principle to cotton reactive dyeing as we found for polyester dispersed dyeing. In terms of what this then means for manufacturers and for the industry as a whole, is that we can deliver very significant operational cost savings, primarily driven by the energy reduction. And so these numbers are actually a little old. So these are numbers from the energy price 18 months ago, and based on mainland China numbers, where we were able to show the cost structure of dyeing can be really transformed by applying our Endeavour process, such that you can reduce the unit cost of dyeing by over 50%. So in this illustration, it shows 65% reduction. And this is actually on a like-for-like basis in mainland China. So this would be quite a lot more now, since the energy prices increased, and it would also be a bigger saving in Europe or the United States. So just to summarize a bit, the Endeavour process, it's a roll-to-roll dye application system. Undyed fabric goes in, dyed fabric comes out. The fabric that goes into the process needs to be prepared for dyeing in both cotton and polyester cases. The fabric that comes out of the machine can be ready to use, or it may need heat setting in a stentor afterwards. We're delivering significant energy and wastewater reductions, so over 85% energy reduction in case of polyester, over 95% wastewater reduction. This significantly lowers the cost of dyeing. And we also believe that by digitalizing the dyeing process, we can reduce the amount of waste in the supply chain, which currently runs at around about 20% based on quality issues and also oversupplying in the supply chain. So that hopefully gives you a bit of a run through on the Endeavour technology, such that you can understand a bit our approach to dyeing, how we're looking to really transform the sustainability cost structure of dyeing and also bring digital manufacturing this process. What I'm going to move on to talk about now a little more briefly is the Navara digital precision finishing system. So this system is based on the same core technology as Endeavour, but we're applying it to the delivery of functional finishes onto fabrics. And similar to Endeavour, we're able to show some quite substantial benefits in terms of energy consumption, cost structure, and also the potential for delivering new innovations. So the Navara technology is essentially similar to a digital printer for functional finishes. What it enables you to do, similar to Endeavour, is apply finishes at much higher concentration than traditional padding, which means we can reduce the amount of energy, water. We can also usually reduce the amount of chemistry required, which delivers a transformation in cost structure and also in energy consumption. The other benefit of our Navara system is that we can apply finishes to side or to shape. And so that means that you can put the finish just where it's needed rather than over the whole fabric. You can think of some examples like this sofa or couch example, where we're putting the stain-resistant finish just onto the contact surfaces for the product rather than covering the product in stain-resistant finish. You can also envisage applications where you put different functional finishes on the same side or on different sides of the same fabric. Such you can, for example, have water repellent on one side, wicking on the other. You can have fire retardant on one side, waterproofing on the other. So this really delivers a lot of innovation opportunities in functional finishing. So to give you an example of what we're able to deliver, this is a real example of HiQ's Eco Dry being applied to a fabric in comparison with traditional padding. So in a traditional padding process, this finish is applied at a concentration of between 4 and 10%, with a wet pickup to typically between 80 and 90%. We are able to apply this functional finish at 50% concentration, so a really significantly increased concentration at a wet pickup of around about 10%. So almost a tenfold reduction in the amount of liquid being used to apply the finish. So what this results in is significantly less energy because you don't need to dry all this water off the fabric. It also enables higher line speed. So drying lines such as stentor line, the length of this or the running speed of the stentor is determined by the amount of liquid that needs to be removed. So you can run processes faster. But the big difference is really the energy. So the fact that you can reduce the energy so significantly also means you can transform the cost structure, which is a particular interest at the moment as gas prices are many-fold higher than they were just a few months ago. So in terms of the broadness of this platform, we've shown broad applicability to a wide range of different finish types. This is showing a range of high Q finishes, which we've proven work well with our Navara technology. So ranging from water repellent chemistries to cooling chemistries to softening agents. So the Navara technology is very broadly applicable. And then we have just a small example here of what 2D patterning means. And so this is an example where we applied a waterproof finish to one side of the fabric and not the other, or not in a sort of 2D definition. So this shows really how you can apply the finish just where it's needed, such that you could imagine, for example, manufacturing waterproof jackets, where you just put the waterproof coating in the shape of the jacket, such that you can really reduce the amount of finish being used. In terms of what the Navara production line looks like, a Navara system is a drop-in replacement for a padding system, and it can also run in line with a padding system, but it would typically be there to replace a padding system. It will be able to achieve significant energy reductions, so between 80 and 90% energy reduction compared to a traditional padding system. We can also reduce chemistry consumption by putting chemistry either just on the side where it's needed or in the two-dimensional shape of the product that's needed. It can significantly lower the cost as a result of the energy reduction. And you can also, by finishing to shape, create new product innovations where you put the finish just where it's needed, maybe on the panels of a seat, on the a jacket where the waterproofing is stronger on the shoulders than it is on the back. And you can create a whole bunch of new fabric finishing innovations through this capability to apply 2D patterning shape. Okay, so that is pretty much everything I was going to present. This final slide is just a little bit about alchemy, and so we'll be very pleased to hear if anyone has any questions on the presentation. We're happy to answer any questions.
That's brilliant. Thank you so much, Simon. Just to add a little bit of a note here, I've seen a few questions go into the chat box. Please could you re-input them into the Q&A panel, and we'll be able to answer them all from there. So let's begin the Q&A. So first question is this for knitted, and what are the limitations?
So the process designs are both suitable for knitted fabric. What we've found in general is that our roll-to-roll process is suitable for maybe 95% of the knitted fabrics that we tested. There are some difficult knitted fabrics with edge curl issues, low basis weight, poorly prepared fabrics where it can be a challenge. But in general terms, the technology is very suitable for knitted fabrics.
Brilliant, thank you. Is Endeavour only able to dye polyester with dispersed dyes, or are also other fibre dye combinations possible?
So we've launched the platform with polyester dispersed dye as the first system, where we've really proven the benefit of the technology. We're currently working with reactive dye stuffs for cotton, acid dye stuffs for nylon and natural fibres, and we also have a pigment-based system in development as well. The system is broadly applicable to all fabric dye combinations, because essentially the physical principles of dye application are the same, and the benefits are very similar from platform to platform.
Excellent, thank you. Is the technology for synthetic fabrics only? Well, apologies if you've already just answered that one.
No, so we're currently focusing on polyester primarily. We will be announcing the platform for cotton later on this year. We also have a strong interest in other natural fibres and non-cotton cellulosics as well.
Brilliant, thank you. What delta E formula was used?
What delta E formula was used? I'm not sure on that actual figure, but certainly if the person who's asked the question would like to send us a separate message, we can send you the technical data, no problem.
Brilliant, thank you. Got a question. Is this technology also working for 100% cotton materials? Has that already been covered?
Yeah, it's 100% cotton. It will work for.
What would be drying? What would the drying media be, and the temperature?
The drying media. So in terms of polyester process, we use essentially a two-stage system where we apply the dye and use infrared radiation to dry colorant onto the fiber. And that also starts the fixation process. So we see some fixation occurring in that process. We then go on to complete the fixation through applying between 160 and 200 Celsius temperature to the fabric, which then takes us to a very high level of color fastness. And so that's in the case of polyester. In the case of cotton, we're using the same dye application process, but we don't fully dry the fabric, and we use a temperature between 100 and 130 Celsius to complete the fixation of the reactive dye stuffs.
Brilliant, thank you very much. What is the green premium as a percentage, and do you distribute your technology globally via licenses?
So I'm not sure I understand the question as to what the green premium is. So I don't know whether you know the answer to that, Lucy.
No, I don't, I'm afraid.
So I'll guess. So there isn't a cost premium associated with the technology in terms of the cost to dye and finish fabric. Actually, the opposite. It's a lower cost process, primarily driven by energy reduction. In terms of a brand's ability to charge a premium for this sustainability, we suspect that is the case, that there is the potential to charge more for the fabric, for the manufacturer and also for the brand, to charge more for products. So there's certainly a lot of, if you like, economic opportunity associated with this technology platform.
Brilliant, thank you very much. I just wanted to send another quick reminder. Please, if you have any questions, please submit them to the Q&A box rather than the chat box, just so that we can get them answered all in equal time. And next question is, how do you prevent IR radiation retaining on the dyed fabric?
Yes, so infrared radiation isn't, so it's non-ionizing radiation, and so there'll be no, infrared radiation is just heat. So the infrared system we use is actually a very efficient way of transferring energy into the fabric. But once the fabric leaves the infrared chamber, there is no infrared radiation retained, other than the fact that the fabric is heated.
Excellent, thank you very much. And what is the speed in the Endeavour process running?
So the process will run at 15 meters per minute. Is a sort of nominal process speed. That's based on 150 GSM fabric running with saturated black. If you run lower basis weights and lighter shades, you can run faster. And likewise, if you run heavier basis weights, it will run slower.
Excellent, thank you. Is there no reduction clearing necessary for dark shades with Endeavour? If not, what about excess of dye stuff residues? So
we don't use any reduction clearing. So going back to a slide in the presentation where I show the dye uptake curve, what we're doing is applying just the right amount of dye to achieve the target shade in the fabric. So what we're aiming to achieve is zero excess dye stuff on the fabric, such that you don't need to go and reduction clear the fabric to remove the decolorized dye stuff. What we found with some fabrics is it's beneficial to add some water after the dyeing process to soften the fabric, which we do in some cases, but we're not using any reduction clearing chemistry, and the volume of water we're using is very, very low, so much lower than traditional dyeing washing processes.
Fabulous, thank you very much. Next question, does this technology work for viscose materials?
So it does in principle. We haven't done any work on viscose yet. So viscose, it's just not a material that we've done any work on, but the principles will all be the same. Viscose.
Thank you. Can the finished fabric be blue sign or OAK-Tex approved if all the used chemistry is blue sign or third party approved?
So I don't know the answer to that question, whether or not the approvals will be applicable to a fabric. They're certainly applicable to the chemistry. I'm not sure what the answer is to that.
No problem. Next question. What about copper color types?
Copper color types. So we haven't done any specific work on copper color types. What we found with the system is it's very broadly applicable to a wide range of different dye types, and certainly everything from saturated black to light shades to neon to some special effects, colorants. We've had no particular issues, but we haven't done any work on copper color types.
Thank you. Next question. Can we get the same sapple hand feel with this process like jet dyeing, where fabrics shrink well in jet dyeing?
Yeah, we can. So we've done a lot of work on hand feel, and we actually have in line with the Endeavour process a softening system, which primarily uses mechanical energy to recover a good hand feel to the fabric after the dyeing process. So obviously that's one of the jobs that a jet dyeing machine does, is applies a lot of mechanical action to the fabric, and we've developed an inline process which does something similar to recover the hand feel of the fabric after the dyeing process.
That's great, thank you. Next question, why only compare with jet dyeing of PES? How's the comparison to continuous thermosol dyeing of woven PES?
So the comparison we make to jet dyeing is because jet dyeing is by far the biggest volume in terms of methodology for dyeing polyester in the world today. The Endeavour machine has a similar level of flexibility, actually superior flexibility, to a jet dyeing machine. So we're very much competing with jet dyeing systems. In terms of what the Endeavour system can do, we can run minimum run lengths of maybe 100 meters, all the way up to run lengths of several tens of thousands of meters or millions of meters. So it can be run continuously. So our direct competitor is jet dyeing systems. Continuous dyeing systems, in polyester terms, generally, for very high volume, limited product ranges, which isn't really where we're competing.
That's great, thank you very much. Next question. Why do you have to add in a softening process? Is the fabric handled affected by the dyeing process?
So it depends very much on the fabric type and the end application. So we apply the softening process in the cases where the fabric hand feel needs to be tuned for a certain application. For example, soft touch fabrics used in apparel, many of those need to be, particularly woven fabrics, need to be very soft. In that case, we use our softening process. In the case of knitted fabric, it's generally not necessary. So it just depends a lot on the fabric type and the end application.
That's great. Thank you very much. Next question. Does the fabric need to be pre-treated, alkali, urea, prior to reactive printing in the cotton process?
No, it doesn't. No, so it's in our cotton reactive process. There's no salt and no urea, and we're not using any pre-padding of alkali in the process.
That's great. Thank you. Next question. What are the BOD and COD values of this process?
So that they've not been determined so far. In terms of the emissions from the process, the Endeavour process can be a zero emissions process. So the only wastewater really generated by it are in washing out between colours, and that's a volume of tens of litres. So you wouldn't even need a wastewater treatment facility. This wastewater could be taken away in cans, essentially, or in IBCs. So the BOD, COD values may be completely irrelevant to our process, because you wouldn't necessarily have any wastewater emissions.
That's great, thank you. Are the preparatory processes the same as conventional? How different is it from spray dyeing?
So the preparation processes are the same as conventional. So for polyester, we need the fabric to be pre-scoured, which can be done continuously. And in the case of cotton, we need the cotton to be bleached and prepared for dyeing. But there's nothing specific about the preparation processes.
That's great, thank you. Does the knitted fabrics need to be prepared before the treatment? Does pilling interfere on the treatment?
So typically for knitted fabrics, they may be preset before our process, depending on the fabric. We haven't found any issues with pilling as of yet, but that's not something we've necessarily investigated in much detail.
That's great, thank you. For which shade, black, deep red, or pale shade, was the comparison of resource saving with reactive dyes on the Endeavour?
These are for dark shades. All our comparisons are for dark shades.
Yeah, all right, thank you. There are two questions for this particular attendee. One is it applicable to wool, which I believe has already been answered. And then what's the maximum density of material you dyed up until now?
So in terms of wool, we haven't done any work on wool specifically yet, but the process would be applicable to wool. But that's not something that we've done much or any work on so far. Sorry, Lucy, what was the second part of that question?
What is the maximum density of material have you dyed up until now?
Yeah, okay. So in terms of density, the process works with fabrics up to about 500 GSM. It's probably a bit difficult to explain in terms of sort of thread count and things, in terms of density, but the sorts of fabrics that we've been able to dye include woven materials for seat belts and for zips, which are pretty dense weaves, wind stoppers, microfiber materials. So fabrics that are generally quite difficult to penetrate.
That's great, thank you. Regarding reactive dyeing, what needs salt for substantivity and alkali for fixation? How to get rid of them?
Yeah, so in terms of the way our process works, we're using let's say a formulation design in the reactive dye stuff liquids that we're applying to the fabric, which eliminates the need for salt and for urea, and that's part of our sort of proprietary technology platform. The alkali itself is part of that formulation.
That's great, thank you. Next question: what kind of dyes are best to use?
So quite a broad question. In terms of the dye stuffs that we're using, we can generally use pretty much all commercially available dye systems. In the case of polyester and dispersed dye, we're typically focusing on medium and high energy dye stuffs for best color fastness and best performance. in terms of cotton reactive dyes, we're using commercially available systems with our own formulations, and typically, we're using high performing systems from major manufacturers. And in the case of pigments, we have a number of systems that we can use with our technology. So the key point to make is it's an open platform, and you can use any dye stuff system with the platform.
That's great, thank you. Next question. Is the Endeavour technology also applicable to fabrics made up of 100% cellulose fibres?
Yes, yeah, it is, yeah.
That's great. Next question. Is the fabric pre-treated with a chemical finish, first like digital printing processing?
No, so there's no pre-treatments required. So it's not like digital printing where you need to pre-apply a pre-treatment. The fabric just needs to be prepared for dyeing, and that would be same properties as traditional dyeing.
That's great, thank you. On the reactive cotton dyeing, is this GOTS certifiable for organic cotton processing?
Yeah, so there's no issue with using organic cotton. I think back to the previous question around the sort of certifications. As a company, our business is to sell machines to manufacturers, and we don't generally get involved in the certification of the fabrics or the products that the manufacturers make with our machines. But certainly, there's no impediment to certifications with using our technology. And in the future, we would anticipate having some level of, let's say, energy passporting associated with clothes and the fabrics, which our machine is very suitable for, because you can measure in line the energy consumption and wastewater emissions that are associated with every meter of fabric that the machines produce. Our technology is very suitable for verifying in supply chains low energy use and low wastewater emissions.
That's great, thank you. Next question. Which system is to be used to apply dye pigment to the fibre? As you said, by high speed?
So the Endeavour system, the dyeing system, would be used to apply pigment-based colorants to fabrics.
That's great, thank you. How does the Endeavour process compare to inkjet spray dyeing?
Yeah, so there's a big difference between the way we apply liquids and the way that inkjet applies liquids. So inkjet will apply liquid in small, low-velocity droplets to just the top surface of the fabric. Our process uses high-velocity droplets with a controlled airflow to draw pico and nanoliter droplets into the fabric to allow really good penetration of both colorants and finishes. And so what we can do with our application technology, you can't do with inkjet. So inkjet isn't capable of getting the color penetration required to do solid color dyeing.
That's great, thank you. For the Navara technology, what is the expected wash resistance?
So what we found so far is that there's no impact on the wash resistance of finishes applied with Navara compared to padding. So the wash resistance is all really driven by the chemistry, and the application method hasn't had any effect on that.
That's great, thank you. Are the machines based on the Jetronica technology platform?
No, so the technology platform is a new technology platform that's been developed by Alchemy, and we use a number of new proprietary technologies which have been developed over the last 3 years or so to achieve quite unique ways of applying liquids to textiles.
That's great, thank you. Compared with Baldwin Texcoat G4, what are the assets of Navara?
Well, so I guess there's a few things to point to. So one would be with our Navara technology, you're able to pattern finishes with two dimensions. So under full digital control, we have an array of around about 1,500 independently controlled nozzles, which allow you to put two-dimensional patterning finishes down. We're able to penetrate fabric in a much more controlled way. Let's say traditional spraying technology typically has droplets of maybe 50 to 200 micrometers, so generally quite large droplets, being applied at high velocity to fabrics, and it's, you know, in general a fairly crude process. Whereas with our Navara system, because what we're doing is creating a much smaller droplet and drawing it into the fabric with an airflow, we're able to get much better properties out of the finishes that are applied to fabrics. So they're probably the two key differences really in terms of the technology.
That's great, thank you. Have you found any differences considering fabric thickness?
So in terms of dye penetration, we've been able to show that we can penetrate fabrics up to about 500 GSM. It's easier to penetrate fabrics that have a more open structure, and we've certainly observed that. But in general terms, our technology is broadly applicable to a wide range of different fabric types, different thicknesses, different densities.
That's great, thank you. Any Navara equipment available for somewhere for trials?
Yes, so we have a test bed in Cambridge in the UK where we can run trials of both Endeavour dyed fabrics and Navara finished fabrics. I'm very happy to engage with customers on to run trials and do evaluations.
That's great, thank you very much. Is there a possibility of this technology coming into the military sector of the textile industry? For example, could this be printed in camouflage pattern?
It could. So our technology platform is capable of simple two-dimensional patterning. So it's not high resolution printing technology. We have not yet really explored the full capability in terms of imaging, but certainly camouflage patterning could be possible with our technology, depending on what the requirements are.
That's great, thank you very much. Could you tell me a bit more about the wash durability of the water repellency applied with Navara in comparison to the padding?
Yeah, so the wash durability is comparable between Navara and padding. Yeah, so we're able, because the way we're applying the liquid is such that it essentially creates a lot of very small droplets that will all be drawn into the fabric and will create almost like a film of a liquid on the fiber surfaces, such that we're able to get very good adherence of the chemicals that are in the liquid to the fiber surfaces, in a way which is comparable to a padding system, where you're sort of forcing the liquid into the holes or the air in the fabric.
That's great, thank you very much. Next question. Also, can we do furnishing fabrics?
Yeah, we can. Yeah, so suitable for home textiles. We're very interested in home textile applications. In particular, applying stain-resistant finishes to a single side, using flame or fire retardant finishes in a way which means they can be used with other finishes at the same time. So I think there's quite a lot of applications in home textiles.
Brilliant, thank you. In digital finishing, are you using spot or process formulations?
So we're using spot formulations.
That's great, thank you. What are the washdown results like compared with current conventional processes?
Washdown. So if I understand this rightly, asking about wash fastness. So what we're aiming to achieve with our Endeavour process is comparability of wash fastness to traditional processes. And what we've been able to show so far is that if you use the right dye stuffs, the right chemistry, high wash fastness dyes. We can achieve some of the most demanding specifications out there. So sportswear and outdoor wear specifications for wash fastness.
That's great, thank you. Do the dye application processes penetrate to the opposite side of the side from the application side? Is there a dual side application or is there a migration?
Yes, it's a dual sided application. So we apply dye stuff to both sides of the fabric independently. And the process is designed such that on each application, we penetrate about 60 or 70% through the fabric. And we do that on both sides such that there's a small overlap between the penetration delivered to each side of the fabric.
That's great, thank you. What is the method of application of the dye stuff on the fabrics?
So the method of application is essentially a liquid jetting process. So we have an array of, in the case of the Endeavour machine, 2,880 independently controlled digital nozzles, each of which jets liquid into the fabric, achieving very good penetration.
That's great, thank you. Have there been any industrial applications of the Endeavour technology, or is this still at prototype level?
So we are the first machines going to market at the moment. So the technology and machinery is fully commercially available. We're very much working with partners and manufacturers and brands on a partnership basis to ensure that the installation equipment is very well supported. But yeah, this is fully commercially available and ready to go.
That's great, thank you. Under what treatment conditions do you see dye migration issues?
So we haven't seen dye migration issues so far with our technology. Like the way we apply the dye and fix it, we've been able to show with electron microscopy, for example, that we're getting very good penetration of the dye stuff into the fibers. And that's driven by the unique way that we apply the liquid. In the case of polyester, the way we use the infrared drying process to initiate the fixation. We were able to get very good or high levels of dye penetration into the fibers. And we haven't observed so far any issues with dye migration.
That's brilliant, thank you. Could you speak more on how the Navara is designed for recycling?
Yeah, so one of the opportunities with Navara is that you can apply the finish to the shape of the product that you're making, such that when you cut out the shapes associated with the product and you're left with cut out waste, that waste isn't coated with a finish, such that means that your cut out waste can then be recycled much more conveniently. So you don't have the waste actually be contaminated with finish.
That's brilliant, thank you very much. Next question, can the Navara system be installed before regular Stentor machine? Are there any chemicals sprayed on the fabric or applied via foam?
So yes, we don't use any foam coating. The Navara system would be installed in front of a standard Stentor machine and can be used in place of a padding system or alongside a padding system. You can choose to use a padding system or the Navara system.
That's great, thank you. In the saving calculations, is the cost of creating the dye droplets included?
Yes, yes. So the calculations are fully inclusive of all elements.
Brilliant, thank you very much. What alkali system is used for the fixation of reactive dyes?
So we use our own proprietary formulation, and when we announce the cotton system later on this year formally, that information will be released.
That's great, thank you very much. What is the approximate financial investment to purchase equipment and set up the process in a plant? Will the technology be available in the US?
So the technology is available in the US. The approximate cost for an Endeavour installation is £1.5 million. Obviously, it depends a bit on the configuration. And in the case of the Navara system is around £500,000.
That's brilliant. Thank you very much. In the case of polyester dyeing, are the dispersed dyes used a regular one or there's some special one? Can we go for combination of dyes or single dyes?
Yeah, so we're using conventional dispersed dyes. We can use single dyes or combinations of dyes. There is some matching in terms of properties, in terms of which combinations work well together, but that's relatively straightforward to do. Typically, if we're using medium to high energy dyes, we can work with quite a wide range of combinations of dye stuffs.
Do you have any dye house partners in India and or China who are dyeing at the commercial scale using the Endeavour technology?
Not yet, no. We have a lot of interest from those markets, but we don't yet have equipment in those locations.
Another question is, where can I see both technologies in operation on a commercial scale? Does the technology work on high poly spandex fabric?
So in terms of commercial scale, the first machines going into market at the moment, we're the first, let's say, early adopters of the technology, expected to be running commercially in the first half of this year. In terms of use of the technology with high spandex fabrics, there are some limitations in terms of what's possible with spandex levels above about 15%. But we have been able to develop processes with spandex polyester blends that have delivered similar benefits, depending a bit on the fabric structure and the end application. So Lucy, just checking, how are we doing for time?
We're okay for time at the moment. We have received quite a high volume of questions here.
That's good. Okay.
Are you happy to continue,
Yeah,
Simon?
fine. No problem. Yeah, that's good.
Brilliant. Presuming it is one machine for cotton and for synthetic, also capacity and pricing information.
Yeah, so sort of referring to the previous answers, really. So it's 15 meters per minute for the Endeavour machine is a sort of nominal running speed. And then in terms of the investment required from the Endeavour line, it's around about £1.5 million.
That's great. Thank you very much. Does it work on woven with yarn between 300 and 1,200 deniers? And can it be done after PU coating or WR treatment has been applied?
Yeah, so the dyeing process has to occur before the finishing processes, typically, and so that would, there may be some exceptions to that. In terms of the different fibre types, there don't seem to be any real constraints around the fibre types that can be used. We've primarily been focusing on sportswear, apparel, outdoor wear type fabrics. There may be some more extreme fabrics with very large fibres, which could be more challenging, large yarns. In general, it seems pretty broadly applicable.
That's great, thank you. What is the colour fastness obtained on cotton dyeing?
So colour fastness is very good on cotton. So we're able to match traditional properties. The cotton reactive process isn't completely wash-free. We do need to use a wash-off process, but what we've been able to show is the amount of water used in the wash-off process is very much less than a traditional process. But in terms of colour fastness, we can achieve 4 out of 5 with wash fastness, with cotton reactive dyes, and sometimes more on the system.
That's great, thank you. How can we apply the same on polyamide 66 high tenacity woven fabrics?
Yeah, so we're starting some work in nylon with acid dyes, and we've shown the system does work well with acid dyes. It's not something we're currently marketing, but we'd be very interested to talk to any manufacturers who want to work in partnership with us on nylon.
That's great, thank you. Is the mechanism the same as dye sublimation?
No, it's not exactly the same as that. So we in the case of polyester dyeing, the mechanism occurs differently compared to sublimation printing, and that's primarily driven by a difference in the start state of our polyester. So when we apply the dye stuff and infrared dry it, the start state is quite different to a traditional sublimation print.
That's great, thank you. Is this system compatible with continuous dyeing and wet finishing processes?
It would be, yeah. Yes, you could integrate with a continuous dyeing system. We, if you like, envisage the process as a sort of batch continuous process, where it's a sort of high flexibility process that could be run in a continuous manner if required.
Thank you very much for that. Next question. How do you fix the reactive or dispersed dyes?
So in the case of the dispersed dyes, we're using a high temperature process to complete the fixation. So we apply temperature between 160 and 200 Celsius to the fabric. In the case of cotton reactive dyeing, we've developed a process methodology that relies on controlling temperature and humidity in the fixation process, such that we can get high levels of fixation in an inline process.
That's great, thank you very much. So is this suitable for elastic knitted fabrics with elastine?
So I think, as per sort of previous answer, high elastane fabrics can be an issue. So elastane levels above 15%. We have demonstrated the process with elastane up to about 15%.
That's great, thank you very much. Just trying to find another question that's not been answered. 1 minute. In Navara, can we use all kinds of chemicals?
Yeah, so Navara allows you to use a very wide range of chemistries. Typically the upper limit on viscosity is about 100 centipoise, so high viscosity fluids can be an issue. Adhesives of some types have been a problem due to them clogging nozzles, and so they're fine. But in general terms, aqueous-based textile finishes are no problem for Navara.
That's great, thank you. Is there a risk of finishing chemical emulsions when applied by this method, leading to risk of instability and fabric staining?
Not that we've seen so far. So we've not seen any issues with emulsion stability. We've demonstrated that we can jet microencapsulated materials with Navara without any damage to the capsules. Although we're using a very high energy process to jet the fluid into the fabric, it's not sufficiently high shear to damage structure of complex liquids. Yeah, we've not seen any evidence for that.
That's great, thank you very much. If this is okay with you, Simon, we may conclude the Q&A session for now, or would you like to continue?
That's good. I think there's been a great range of questions, so we covered a lot of ground. So I think, if you're happy with that, I think it's been a very good session, and thanks very much to everyone for all their detailed questions.